Hello, my name is Carlos Mario Zapata, and this is the final project of the course Machine Learning Foundation for Product Managers. This is the description of the model. I said that is the preconceptual schema for explaining what are the main goal of our model. We have a city, and this city has a combined cycle power plant. The city has ambient pressure, ambient temperature, and relative humidity. And inside the power plant, we have the exhaust vacuum. These four features are selected as the possible features for the model. Uh, our task is predicting the net hourly electrical output. This is the intention of this model. In the machine learning model, we have a modeling approach that is predicting the net hourly electrical output of this power plant. The possible features to be used are the ambient temperature in Celsius degrees, the exhaust vacuum in centimeters of mercury, the ambient pressure in millibars, and the relative humidity in percentage. We have a data set with more than 9,000 observations, and the possible algorithm is a linear regression. I opted for a model with two iterations. I constructed the model in two iterations. The first one, for the first one, I selected the Python language with the libraries pandas and scikit-learn. The approach is a linear regression with all the identified features and assigning 70% of the set to the training set and 30% to the test set. The results are in these values. We have four coefficients for as a result of the model. As you can see, the lower one assigned to the air pressure. So this is one of the intentions of the second iteration. I used three metrics for evaluating the performance of the model. The mean absolute error with a result of 3.6, the mean squared error with a result of 21.2, and the root mean square error with a result of 4.6. The interpretation is that the model performs well for predicting the values of the net hourly electrical output, since the average of the observation is 454 megawatts per hour, giving an error of 1%. The low coefficient of air pressure leads to a second iteration without this feature in order to assess the behavior of the model. So the second iteration is again in language Python with the libraries pandas and scikit-learn. The approach is a linear regression with three features: ambient pressure, exhaust vacuum, and relative humidity, and assigning 70% of the data sets to the training and 30% to the test set. The results are summarized here. We have again three coefficients for the variables, and I use the same metrics again with almost the same result. The mean absolute error with 3.6, the mean square error with 21.4, and the root mean square error with a result of 4.6. The interpretation is that even though the results are practically the same, the performance of the models is slightly better with the incorporation of four features. So this is the way in which I evaluated the results of the model. Thank you so much, and see you in other time.